Hello everyone, welcome. This is Aurora with Supercharged Science, homeschool science curriculum and resources for K through 12 kids. Whether you're a homeschooler, at home, studying independently, home study, you name it, we have an amazing lineup of science activities and experiments for you guys to enjoy. So today we are going to talk about lenses and light and optics, and we're also going to make our very own marshmallow roaster. Now this marshmallow roaster only needs a couple of items. You can see them here. You'll need either a packing tape or hot glue gun. You'll also need something to roast. It doesn't have to be a marshmallow. It can be. And also you'll need a skewer, which you can see here, and something to cut the box with. If you're a kid, we don't want you using razors, so make sure you've got a grown-up handy to help you with that. You'll need some reflective material like aluminum foil, and you'll also need a special type of lens. I'm going to show you what that is in a second, and a box. So very similar to the materials we used yesterday when we made our solar cookies. By the way, thank you everyone who sent me pictures. That was so cool. Let me see if I can pull a few of them up. We had a number of people who really enjoyed making the solar cookies. Here, wait, let me see if I can get these on the screen. And this person recorded the temperature and how long it took, and their experience with that. So thank you for sharing those. And so if you shared images with me and gave me permission, then we're going to share them with you. You can see more solar roasters here. We're not quite sure what everybody went cooking, what they created, but we know that they had a good time doing it. And there is one more picture I'm trying to bring up here. Oh, looks like two more pictures. Oh wait, we had that one. Let me see. There was a couple others. There was one super fun one. Okay, I'll find it. And we also had sent into us complete instructions for how to capture a parent. So Ellie did this, my daughter, and so she was very excited to be able to share this with everyone. She figured out, we have motion detector lights for night lights. So usually the house is dark, but if you go walking by them, then the night lights, they plug into the wall. And so we have some night lights down, or outlets down low, and so every time you walk by with one of these detector nightlight things, then the nightlight goes on, right? So they're motion detector. So she decided to build the electric eye and attach it to it. So every time that thing went off, now it also has a buzzer that goes off. So she was super excited, and so she called it her parent trap. And so she caught me last night. I didn't even know what was happening until a buzzer went off, and I'm like, where is this coming from? And I thought, oh, I'm foiled by my own kids. Okay, so let's go ahead and get started. Let's see. We have, if you'd like a shout out, definitely give me your name and where you're calling or where you're connecting from. So if you're outside the United States, make sure that you're also including your country so I can say hello to you. I did promise to talk to you about the lens you're going to need. It's different than a handheld magnifier. I have a handheld magnifier around here somewhere. Let me see if I can grab it really quick. Maybe I can't. Rummage, 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 rumble, rumble. Here it is. Sorry, disappeared for a minute. Okay, so these two are different, and we're going to talk about how those are different and check that out. So, but the experiment today will not work with one of these. Not quite powerful enough for what we're doing. You need one of these things, and this is called a Fresnel lens. Now this lens is, we're going to talk about what it is, but you can tell it's a lens because it's a page magnifier. It's really thin. It's usually bendy plastic, and you can get them. I got mine for $1 from the store. So grocery stores will sometimes have these. You'll also find them where people sell reading glasses, so like in drugstores or pharmacies or something like that. So you'll be able to find those as well. So here's the materials we're going to need. Let me go ahead and say a few hellos to our friends. We've got some folks, Audrey and Gabe and Aiden from Texas. Good morning. We also have Meridian from Idaho. Hello, hello. We have Gavin from Oregon with his mom. We have Natalia and Sophia. We have Raj and Raya from Colorado. Welcome. And we have Haley from North Carolina. We have Kaylin from South Africa. Welcome, Kaylin. We have Oliver from Germany And we had a family from Norway. I didn't get their name though. They went by really fast. We have Clara, Cadence, and Camden from Minnesota. And we have families from Michigan and Idaho and Tennessee. And we have a number of folks that are emailing in. So let me get those as well. So we have a family from the Philippines. So welcome. And we also have, I'm going to actually just say it because they don't always type it in, but we have a couple of families from Australia. So I know it's like 4 a.m. there. So they get their kids up, they go to bed early, they get up so they can start their day with science, and they get like extra kudos because anybody that gets up at 4 a.m. just is like, well, they're just amazing. So welcome from the other half of the hemisphere. So good morning. And so let's go ahead and get started. Oh, I did have somebody who made the electric eye and asked if it could also be called the electronic rooster, or the electric rooster. That's a perfect name for it. So they actually made their electric eye, hung it out the window, so when they were sleeping during the night with the window open, and then when the sun hit it, the thing went off, and it was like an alarm for the sunrise. And so he called it an electric rooster. Okay, so that was a project we had done, was it last week or the week before? I think it was last week when we did electricity and electronics. So you can go ahead and look at any of our past videos in the archives. Facebook automatically archives all of our videos that we've done. They don't really do it in a very organized way, but they are in there, so you can definitely look those up. We have a couple of quick announcements. If you are interested in having your kids participate in our live science camp, our summer science camp, it's online. Everything's accessible to you 24/7. It has interaction. It's totally fun. Won't even feel like work. It will keep the education going throughout the summer, and kids, you'll get to be able to do all kinds of projects and experiments. We talked a little bit about this last time. That's what the link is right here. It's superchargedscience.com/summer camp. So if you go to that link, we've actually extended it for another day. So you can go to that link today after we're done with class and learn more about what summer camp is. But it's totally fun. It's really exciting. And we're really glad to be bringing that again back to you. So the registration for that is just open just today. We're only registering people just one day. We just want to see if anybody's interested. And if they are, then we're going to go ahead and do and be able to open it to the public, but much later. So if you want to get an early bird spot, you can go ahead and do that now. So the registration is at superchargedscience.com/summer camp. Okay, now I did promise to tell you about our science fair, and it turns out that I'm not quite ready. So we were going to release our science fair. We're actually going to release it next week, and you will have you will have a couple of weeks to complete a science fair project and compete for prizes from Supercharged Science. And so it's open, it's free, anyone can register. You don't have to be a member. It's open to everyone. You can enter in your project, and just by entering, you win a prize. And then we also have a grand prize for our grand prize winner. So that will be available, and it'll be something that I actually mail you in the mail. That it'll be a big science kit that you can actually look at and build. And it'll have complete instructions on DVD as well. So that will be coming up. So it'll be next week. I was hoping to do it today, but we just got so swamped with requests and stuff. So we took care of our customers first. So we'll just release that next week. So I'm excited. Supercharged Science is hosting a science fair. We did this about 5 or 7 years ago. We had a ton of great entries. Really, we had hydraulic earth movers and underwater robots, and it was amazing the type of science that went on. It was really, really cool. Okay, so let's go ahead. How long are the sessions for summer camp? So the summer camp, everything is pre-recorded. So the videos are between 5 minutes and about 60 minutes, depending on the activity. So easier activities, shorter. More intense activities like flashlight laser tag and the go-karts, those are going to be much more intense. And so like building the robots and the beam bots that I showed before, where you take apart cell phones and make them into robots that are work by the power of the sun, those you're going to need more time for. So everything's available to you. You don't have to go in any particular order. And you can watch the videos as much as you'd like. And I am on there live interacting with you as well periodically, and also through our questions forum. Okay, questions. Let's go ahead and get started. Oh, we have Oliver and Sully. Hello, welcome. And Abby from Ontario. And we have India from the UK. Welcome, everyone. So as you can tell, we've got students worldwide. And it's just so much fun to be able to participate for everyone to be able to participate. Okay, use the comment box during class to ask me any questions. When we do our video, I'll go through and actually while you're watching the instructions for the the roaster today, and I will answer those questions for you. So if you want to interact with me and you want me to answer a question that has to do with science and what we're talking about, type it in. I'd be happy to answer those for you. Okay, you ready? If you're ready to say, oh yeah. Okay, so today's topic is going to be about light and about optics. Now, I do want to warn you, today's project, it works. It doesn't look like it works, and when you start to put it, when you actually have the thing built and you put it outside, you're like, nothing's working, and you'll reposition it, and all of a sudden, well, the box can actually catch on fire. So you want to be really careful with this project because it'll look like nothing's happening and then it can really get away from you. So make sure you're doing this in a way that if something does start to melt or char or smoke, that it won't cause a problem. You're not doing this in dry grass. You're not doing this in a pile of dead leaves. You're doing this, you're being safe, and you're being smart about doing this project. And so I was kind of on the fence about doing this one because of this. Usually there's one kid that I hear about who wasn't very smart. So please do keep this in mind. You do want parents around for fire safety, and you also want them around for using the sharp objects that we are going to be using. Doesn't it sound like a fun class? And tomorrow, I forgot to mention, tomorrow is the parent-kid workshop. So we're going to be making steamboats. So you will need a parent with tomorrow's class. So you can still make the project, just make sure you've got a grown-up around because we're using hot steam. Okay, so enough announcements. You guys ready? Let's get started. Okay. So we've already touched on light. We did light with holograms, and we've done the different colors of light. Now it's time to actually talk about the speed of light. Does anyone know what the speed limit of light is? Tell me out loud. What is light's maximum speed? Does light even have a maximum speed? I should ask you that question first. Or is it infinite? Can light go infinitely fast? I mean, as soon as you flip on the switch, I mean, it's just boom, the whole room is lit, right? Doesn't it seem like it's really, really fast? So tell me out loud while I get my slides, what is light, and is there a speed limit or not? Go ahead and tell me right now. Type it in the box or tell me out loud. Pretend I can totally hear you. We're having a conversation about science. Tell me out loud. I'm going to fire up my slides. Okay, go ahead and tell me what you think about light. Okay, so does light change speed? So light is energy that can travel through space. That's pure and simple, super easy definition. The second question I'm asking you is light, does it have a speed limit? And if so, can we change that speed limit? Can we change the speed of light? Yes or no? What do you think? The answer is yes. Depending on what light is traveling through, it will change speeds. Light can travel through objects sometimes, like a glass window or through a prism, right? But when it does this, it will slow down from its maximum top speed of 186,282 miles per second to something slower. Now take a look at that number. I remember when I first learned this, when I was a kid in grade school, I was amazed there was no decimal on the on the end of it. Like, why is it 186,282.9 or something? Like, why isn't it an integer? Why isn't like decimal numbers packed there? And it has to do with how we define a second and how we define a meter. And it just works out that way just because of how we defined it. Okay, so back to here. So how slow light goes depends on the material, whatever the stuff it's traveling through. It goes slower when it travels through different things like air in our atmosphere, or through your car window, or a glass of water. It takes time for light to travel, and this is the important part. It's not instantaneous. So you can tell that light changes speeds because of how it bends when it crosses into new territory. So going from like air to water is crossing a boundary. Going into new territory, from air into water. Going from air into glass, well, we were in air and now we're going into the new territory called glass. So anytime light goes from one thing to another, it crosses a boundary, and every time it crosses a boundary, it has to change speed. Sometimes it goes faster, sometimes it goes slower. So when you look out the window, light is going from air to glass and then back to air again, and then it hits your eyeball. You with me so far? Okay, so technically it went through space, from the sun, through space, the vacuum of space, and then it hits our atmosphere, and then goes through a window, and then goes back through it, because my eyeball isn't like attached to the window, and then it has to go through more air, right? So it's constantly changing its speed, right? Just like a car on a freeway or a car in traffic. So a physicist from Harvard had the idea to fire a laser through a cloud of BEC, which is the fifth state of matter. You know, you have like solids, liquids, gases, plasma. BEC is the fifth state. It's called Bose-Einstein condensate. It's a state of matter where the atoms are like super duper cold. It's like a big atomic mush because the atoms are barely moving. And she found that inside this BEC cloud, she could slow light down to 15 miles an hour. So originally it's going 186,000 plus miles an hour, miles per second. And then she put it through this cloud of stuff and she slowed it down to 15 miles, not a second, but per hour. And there she is right there. She also figured out how to stop the light pulse dead. She got it to go to a dead stop inside, and then how to release it so it continued. So she kind of basically made a hologram is what she did, which is really super cool. Now, her research is still going on. And so this is just some of the fun things you get to do when you study physics and you get to like play with big expensive lab equipment like you saw her lab initially when the video started. Okay. So so what, right? Okay, try this right now. Do you have a cup of water nearby and a pencil? Go ahead and try it right now with me. Go ahead and take that glass of water and stick a pencil in it, okay? And then look at that water glass. What happened? Let me show you inside just in case you don't happen to have a glass of water nearby. Do you notice how the pencil appears broken? Can you move your head around the glass in all directions, all the way around, and find the spot where the pencil is like the most broken, and also where the pencil seems to be fixed, like it's all one pencil? Do you see that? So, okay, so what's going on? All right, magic trick number one. Okay, so light is changing speeds all the time, right? It's going through different things and it bends by different amounts depending on what it's going through. So light in air travels nearly the same speed that it would in outer space, but if you shine it through clear stuff like glass or water, it slows down a lot more. And you could slow it down even more if you shine it through something more what we call optically dense, things like cooking oil or a diamond ring, or a diamond like in your mom's wedding ring. So that's going to bend the light even more. Now take a look at this wine glass. So this is just a glass of water in a dark room, and we've got a green laser. This will work with red lasers too. And so what we see here is, look, we're shining the laser down. Notice that part of it reflects off. Most people don't even realize that. They'll just think the whole thing passes through. It does, part of it, but does pass through. But do you see how it's offset? Do you see how it's not straight through? Okay, so light is bending. It's just like this pencil is appearing to be broken. The light beam is appearing to be broken. It's bending. And notice that this angle is not the same as this angle, right? This one is more straight up and down, and this one is tilted over a little bit more. That bending is what we call refraction. And so the bouncing back is called reflection. Okay, so refraction is bending. Reflection, something is reflecting off. So when we point this laser at the water, you want to look for a dot on the ceiling and a dot on the table, okay? And that you'll be able to find those two dots. They'll be different intensities, as you can tell, but that will tell you the path that the light has been traveling. Okay, now you'll also find dots in other places. Don't worry about that now. So every time, so it's going to pass through here, and there's actually a little reflection going off the inside of the glass, and as it passes through, so there's more, but don't worry about that now. Here's your test. Ready? For this picture here, how many different territories did the laser go through? Let's count. First, it was in the air. That's 1. Then it hit the water. That's 2. Then it hit the glass. That's 3. Then what? Then it hit the air. That's 4. So it crossed 3 different boundaries. How many times did it change speeds? 1, 2, 3, right? It had to change speeds 3 times. Okay, so why is this important? Because we can use this to do useful things. So lenses, like things like magnifying lenses and eyeglasses, they bend and distort the images in special specific ways to magnify things. For example, you ever taken a magnifier and run your fingers over it? It's kind of like there's a bump in the middle, huh? So you remember, so this bump feeling, so the glass is thicker in the middle than it is on the edges. So water does this also. I had a picture of it here on the slide. Water is nature's magnifying lens, right? Because normally it wants to stay curled up in a ball, but because of surface tension, it wants to stay in a ball. But because water is heavy, it tends to like flatten it out and kind of make it a teardrop shape or kind of a squished oval. So water is nature's way of making magnifying lenses, right? Okay, so this type of lens is called a convex lens. It magnifies the light and spreads it out when light passes through it. You can actually use this idea to make a compound microscope. If you have two of these, they don't even have to be the same. They can just be two of these, and you stack one on top of the other and look through both and bring them into focus. Now I have a compound microscope, like those fancy ones that are like 200 bucks. So initially, when you're first getting to know this idea and kind of playing with lenses, you can put 3, 4, 5 of these things together and really multiply the magnification out. If you take this and you just look outside of a window, now I've just made a refractor telescope. That's all it is. We're taking the incoming light, magnifying it, adjusting the focal point so everything comes into focus nicely. And that's all it is. So we can use this idea of bending and distorting to our advantage. Speaking of advantages, wouldn't it be cool to actually build one of these things and maybe cook our food with it? Wouldn't that be fun? So if you tried this just with a regular magnifier, everything will come together in one solid point, and it'll be so intense that it'll catch whatever is on this end on fire. So we need a different way to approach this. And honestly, these aren't nearly as strong enough because we need multiples of these in order to cook our food. So here is another experiment that we are going to do today. All right, so Fresnel lens is a lot like a magnifying glass. So convex lenses, we just talked about how they're thicker in the middle. You can kind of feel it with your fingers. This type of lens, a Fresnel lens, was first discovered in the 1800s, and the intent was to focus a beam of light. So they were actually used in lighthouses. And do you see this concentric rings, like rings of a tree, when you cut the tree in half and you kind of look at all the concentric rings? Okay, so imagine taking a plastic magnifying lens and slicing it, just slicing it like hundreds of times, and then stacking those together in rings like you saw in this picture here. And then each ring is like slightly thinner and slightly at a different angle because we're always focusing near the center. Okay, and so if you also make it flat on one side and angled towards the other, now this is what a Fresnel lens is. Okay, so you know that you have to adjust. If you've ever played with one of these magnifiers, you know that you have to adjust the distance. It just doesn't work at any distance for anything. There's a focal point, right? There's a point at which you need to be at in order to bring things into focus. Okay, so each one in the Fresnel lens, each one of these rings has its own special focal distance, but now they've aligned them in such a way where they all come together into one point. So take your lens right now. So if you have a magnifier, you can use that. If you happen to have one of these, bring it along as well, and walk around the room right now. And I want you to find 3, 4, 5 different objects and notice how the focal point is different for them. Okay, just go ahead and play with them just for a minute. Walk around. How far away, take in and notice how far away this thing needs to be for you to bring things into focus, and how far does the Fresnel lens need to be, okay? So because these are two different lenses, they're gonna have different focal points. They may have different focal points. I want you to get to know this one a little bit more, and notice, is it different depending on if it's the smooth side towards you or the side with the ridges towards you. Okay, go ahead and do that now. Kind of walk around a little bit. For those of you who don't have your materials, this is your time to get your pencil and your paper because you're going to write down the instructions on how to build your roaster box. You ready? Okay, so I want you to just notice, how does the lens make things look different around you? What do you notice? Take a minute, walk around, see if you can figure out the secret to this lens. Take a look at words on a page, maybe your sister's elbow, maybe there's a photograph on the wall. Okay, do you notice anything about how this lens works? What do you notice? Go ahead and do that now. Okay, so I hope the thing that was the most obvious is the weight, right? Fresnel lenses are really light. This guy is heavy. I mean, I could probably get 25 of these for one weight of one of these handheld magnifiers. So that's why when the lenses are really large, like for lighthouses, that's why these were first invented, because they wanted to reproduce optics that work with the same focal length for a fraction of the normal weight, of the original weight of traditional lenses that were used at that time, right? A lot less mass, a lot less material could be used to manufacture even more of these. So this Fresnel lens in the project that we're going to be doing, it's going to focus the incoming sunlight much more powerfully and intensely than a handheld magnifier. But focusing the light is only one part of the story with the roaster. The other part is how your food cooks as the light hits it. Now, if your food happens to be like a white marshmallow, it's going to cook slower than if you have like a piece of chocolate in there, or maybe like a hot dog, which is usually darker than a marshmallow, right? So you may notice you've got burn spots on your food, which is why you want to put it on a skewer so you can rotate it to kind of cook it a little bit more evenly. Now, as I mentioned, this roaster may seem like initially it's not going to work, it's not working, and all of a sudden, hey, who put this charcoal briquette in my roaster? So you want to make sure you really keep an eye on this one. Okay, so let's learn how to use one of these, how to build it and to cook and roast your food without using coal or oil or electricity to cook your food. You ready? So a conventional oven, the kind that's in your house, usually uses about 1/2 kilowatt hour, about 4 cents, to bake a batch of cookies. So when you baked solar cookies yesterday, you saved about 4 cents. Okay, so most people spend an average of about $72 per year just to operate their oven. So it's usually one of the least expensive things to run in the household. By contrast, heating the house and also heating up the water, and if you have air conditioning, those tend to be the energy hogs in your house. Okay, so let's take a look at how to actually build this, this roaster using this special lens. Okay, so let me go ahead and open up the project, which is in here. And we're going to go into, this is my online eScience program, and the video, I just happen to know exactly where it is. We're going to go into renewable energy, module 2, the more advanced projects. And we're going to go down, 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 down. Solar boat, solar car, wind turbine, marshmallow roaster. Here we go. And steamboats is the one we're going to do tomorrow. Okay, and so we're going to go ahead and, oh, and this thing up here, somebody was asking me about this last time. This is a solar battery. So we're actually making a solar cell out of pieces of copper, and you can hook it up and you can actually measure the voltage. So we actually made our own solar cell. Okay, marshmallow roaster is this one. Okay. Okay, so let's make it big. Are you guys ready? Let me go ahead and turn up the volume. To make our marshmallow roaster, we're going to need a few things. You're going to need a cardboard box, and the cardboard box needs to be larger than your page magnifier. Now, this is a Fresnel lens, regular page magnifier. It's bendable, it's made out of plastic, and if you feel one side, you can feel the grooves, and if you feel the other side, it's very smooth. Okay, so you want a large 8.5 by 11 or similar size, okay, of that. You're also going to need something to roast, like a marshmallow, and something to stick it on, like a skewer, okay? And also some tools, like a razor or a sharp pair of scissors, and also a hot glue gun. And you're going to need a roll of aluminum foil. Okay, let me show you how to do this project. So your first step is to take your razor and cut out a hole that's slightly smaller than your lens, okay? And so I'm going to do that on, actually on this side. I can see that actually my lens is just about the same size, so I'm going to cut it a little bit smaller. So I've got my hole cut out here, and you want to just make sure that your lens will fit. Now before you stick your lens in, just kind of run your fingers along it. Find the side that has the grooves in it. That's the side that you want facing out, okay? If you have the smooth side out, it won't focus as well. So smooth side goes towards the box, and the grooves facing outward. You can go ahead and secure that in. And you want to use some hot glue on there to make sure this is nice and flat. Now once you have your paint, okay, so I'm going to pause right there, and if you use hot glue, chances are it's going to melt once you start this. So since I've made this video, I've also recommended using packing tape instead, just something to keep it in, or you can even make little cuts here to unfold and kind of hold it in. You just want to make sure the screen doesn't fall out. It looks like a little TV, doesn't it? Those old CRT TVs. Okay, so go ahead and you don't have to use hot glue. I would recommend just tape. That works just fine. Page magnifier in here, just kind of double check, make sure you've got the grooved side pointing out. Okay, now you're going to look inside your box, and do you see how you've got the 4 sides all the way around, and also when I close this flap, this will make the 5th side. Well, all those sides actually need to be covered with aluminum foil, and the reason is you want to make it as shiny and as reflective as possible, so you actually don't burn the box itself, okay? Because this is going to bring the incoming light and really focus it, and we want to make sure to make it as reflective as possible so you don't actually catch your box on fire. So here's what we want to do. Using your aluminum foil and your hot glue gun, go ahead and cover every surface except for the lens, of course, with aluminum foil. Make it all shiny inside. It doesn't matter if it's wrinkled or anything like that, or it overlaps. Just make the whole inside of the box shiny. Okay, so I'm going to interrupt myself again. So hot glue, I found, doesn't necessarily work all that great. You want to use some kind of packing tape, or you can staple it in there. It's your choice. Just make sure the foil stays securely attached to the outside. So you get what we're going for. So one side is open, it has the lens with the ridges facing out, and then you're going to completely put the inside, you're going to make the inside all reflective. Okay, so here we go. Once you have your entire box filled with aluminum foil, you can go ahead and close the flaps and seal it shut. And go ahead and tape this side shut. Now your next job is to actually cut a small window about twice the size of the marshmallow, kind of in the middle here. Now when you cut your window, you want to cut it like 2 shutters, and you want to open them up, and your last step is to take your skewer and poke a hole through one of the doors, and then through the other door. Okay? This is where you're going to put your marshmallow. So you can go ahead and back it out and insert your marshmallow, and then put it back through. Your solar roaster is ready to cook. All you need to do is place this outside, and as long as the grooved side is out and your marshmallow is in place and you have foil on the inside, you should be ready to go. These are very special types of lenses that are curved, and that's what the groove... Okay. Okay, so you've got most of what you need in that experiment. Yes, now I'm just going to describe what the lens is. I wanted to show you something that you can do if you have a really big lens. This originally is where this project came from. Look at this. So this actually this is a 40-inch across, 40 by 30 inches. This came from a projection TV, one of those old-fashioned ones. And it's supported by a frame, and this person put it in the sun and focused it on this ledge here. On this ledge were a couple of pennies. Now these pennies got melted by this lens, and it doesn't have anything to do with it doesn't have as much to do with how big it is versus how powerful it is. So when you make your lens, when you make your roaster, just be aware that you are really focusing a lot of energy onto whatever it is. So if you make this and it doesn't work, you've got 2 things that could be going on. The first thing is your lens isn't pointed towards the sun. It sounds a little funny, but it happens. One woman actually said, "Oh, I have to take it outside." So you have to take this outside, and you have to make sure it's pointed at the sun. Okay. And so that's thing number 1. So number 2, what can happen is your marshmallow is at the wrong spot. So before you actually make those flaps to nail the marshmallow in, go ahead and take it outside and simply play with the distance that the marshmallow should be at for you to start to see it starts to melt. So you can use something that melts even faster than marshmallows. Things like cheese cubes or a piece of chocolate will instantly show you, because they are the melting temperatures are so close to room temperature. They'll begin to transition from that solid to liquid state really quickly, so you can see it. So those are the two things you need to remember. Yes, it has to be outside. You have to have sunlight. So if it's snowing or raining, it's not going to work today, but make it. So as soon as those clouds part and you've got sunlight, you should be able to go outside and actually make this work. Okay, so let me answer a couple of questions that came in. Questions. Let's see. Let me see. Yes, there are lots of people that have amazing roasters. Oh, it looks like maybe the sound wasn't working. Let me rewind it then just a little bit. You want me to do that for you? Okay, let me rewind it so you can see it. You can go ahead and close the flaps and seal it shut. And go ahead and tape this side shut. Now your next job is to actually cut a small window about twice the size of the marshmallow, kind of in the middle here. Now when you cut your window, you want to cut it like 2 shutters, and you want to open them up, and your last step is to take your skewer and poke a hole through one of the doors and then through the other door. Okay? This is where you're going to put your marshmallow. So you can go ahead and back it out and insert your marshmallow and then put it back through. Your solar roaster is ready to cook. All you need to do is place this outside, and as long as the groove side is out and your marshmallow is in place and you have foil on the inside, you should be ready to go. These are very special types of lenses that are curved, and that's what the grooves are that you're feeling here. They're small little curves, and they're curved in a way so the focal point never changes. It's always the same. The focus point, the point at which all the energy is focused, always remains the same no matter how far away your light source is over here. So that's handy to use because all right, does that make sense? You guys have some homework to do now, right? You're going to not just roast marshmallows, but lots of other things that you can cook with this as well. Okay, so just quickly to recap for today, you've got a solar roaster that we made, solar cookies, and we also, if you missed Monday or Tuesday, we did batteries. We also did how salt can be used to store energy, and then we talked about concentrated solar power plants that are being developed today. So we have a lot that we've done in the area just of solar. We really should just call this week like solar and batteries, huh? 2 different topics. Tomorrow we're going to move into the energy of steam and how much energy is actually you can get out of steam as well. We're going to make some boats that you will be able to run on steam power, which is super cool. So your kids will definitely want to take a bath tonight is what I'm guessing. So all these steamboats zooming around. Okay, so there's a couple of quick last minute announcements. We do have our science fair. We are going to be announcing that next week. So I know I meant we were going to do it today, but just isn't ready yet. So next week we're going to be announcing our science fair. We're also going to extend the science camp as well. If you want to stay on with me, I'll just show you what science camp is for those of you who would like to join us this summer with me and my family. We will be doing summer science camp. It's completely online. You'll have access to the experiments and videos all summer long. If you're part of our online summer program anyway, then that summer camp is included in your membership. So you don't have to buy anything else. We just give it to you as a way of saying, hey, thanks for being part of our family, our science family. So, okay, so you guys have your experiments. I will see you tomorrow. If you want to learn about science camp, stay here. Let me show you just real quick. Okay, so, and I will answer a couple more questions that have come in. Let's see, use tape. Oh, do you have to use hot glue? Heather is asking, and the answer is no. You can use something that doesn't melt quite as easily as hot glue. You could use staples, you could use tape, you can use any other method of just attaching that foil inside and also making sure that the lens stays upright. Okay, what ages are you enrolled for camp? Okay, so let me answer that question for you as well. I hope you guys have enjoyed this class. I've really enjoyed putting these 7 weeks of content together for you. We will be doing content next week as well. It's going to be a little different since we're kind of moving into our science fair season. So I'll be putting announcements about that as well over the weekend. So I hope you guys enjoy that as well. So make sure you tell your friends and tell your family everything you've been learning today and this week, and actually, well, your favorite classes with Supercharged Science. That would be really helpful. Now, for those of you who have been following me for a while, take out your fingers and type in the actually anybody, type in the comments, tell me which class you've really enjoyed the most. Was it chemistry? Was it holograms? Was it catapults? Was it rockets? Was it roasting marshmallows? Was it shocking your parents? Which class did you really, really like the most? So tell me that as I get my slides up here for science camp. There we go. Okay. So go ahead and do that now. So thank you guys so much for joining me, and I will see you tomorrow. For those of you who want to learn about science camp, how about we actually go to science camp? Here we go. Okay, so here is Supercharged Science. This is the online website. And so we simply would hover over the little hamburger here. These are all the topics that our program covers. These are all the grade levels. And this is all the extras, like how to keep a science journal, how to do the scientific method. Aha, I see science camp. Do you see the one below it? Science fair projects are in there, careers in science. There's a whole math course, and there's an archive of all the live classes that we do. Okay, so we click on Science Camp, and then we go into here. Notice the dates of Science Camp. What dates are those? June 1st through August. Yep, that's right. So that means when June 1st rolls around, and possibly earlier, we are actually getting a number of requests from people saying, will it please open before June 1st? So we're looking into seeing how we can do that. So these are the dates that it will run. And so if you're not a member of our program, these are the dates of Science Camp. If you are a member, you will actually have access through November 1st. So we keep it open even longer for you. So we would, there's a video here of me starting a science camp, and you can't see it, but there's like 100 kids in this room. We're, I think, in Alaska at this point. And so you can click here where it says Access Summer Camp. Okay, and these are the labs that will be available. So there's a flight lab. This one I think has like 35 different projects. Kites has like a dozen. Rocketry has a couple dozen. Robots is huge. Electricity is huge. Physics is huge because it's motion and sound. We also have laser labs. We have astronomy. Chemistry is enormous. And we also have our new Spy Science Lab, which is really fun too. And each one of those has a release date on it, so you can see when that will be released for the content. So it's kind of like drinking from the fire hose. So we do the first block of 4, and then the next block, and then the final block. Now, if you notice down here, it says Advanced E-Camp. Now, that's for kids that are either advanced middle schoolers or they're high schoolers. And let me take you into that so you can see that one as well. I have it open over here. So for these projects, these are for high school kids. So they're going to be doing some more advanced things. They're going to be building and flying real rockets, and they're going to be soldering. They're going to be making laser light shows and robots and space-age laser communicators, underwater robots, and making even more robots and trebuchets and potato cannons and soda cans engines. This is a Stirling engine made entirely out of soda cans. There's a class in analog and digital electronics, robotics, and there's go-karts, and you can actually make all of these things. And so we actually give you access to all of these projects at once because they are so intense. Most of these projects you will not finish in an afternoon. It will take several days to complete just one project. These two down here I think have over 100 projects in them each. So there's a lot to keep your kids interested and excited all summer long and keep that learning going, so you don't get when fall starts, you're like, wait, what were we doing again? So they've been actively engaged and learning, and it doesn't really feel like school because it's so much fun. There's much less academics, but that doesn't mean they're not learning. It just means that there's much more hands-on projects. They're not going to be staring at a computer screen reading. They're going to be just like we did today, where we had the main idea, and now we're going to make it even better. And now you're going to go out and make your roaster. How many can you make your roaster roast like even larger objects? What changes can you make to your roaster from today's projects that'll make it work even better? different sized box, different kinds of reflective material, different kind of lens. What if you stack more than one lens? What if you add a magnifier in there? I don't know. Let's find out. So this is just phase one of these projects. So a lot of these projects, they all have step-by-step detailed instructions, and they have written content, and they're already available to you. And the interactive part is when you have questions, and then I come back and answer those for you. Now, we also will have live interactive time as well, but that tends to not be very popular simply because we have kids all over the world participating. It's hard to find a time that everybody is happy with. So traditionally what we do is we'll have like a question and answer forum that's live, and that goes on for multiple hours, and that's much easier to be able to communicate with kids. Okay, so let's see, any other questions? If someone completes all the projects, is that comparable to college educated for science? That's a really interesting question. This is not a college course. It's not a college prep course because the focus is different. The focus of these projects is to get your kids building something and get them used to using tools. College courses have a specific goal. So at the end of the year, you can ring the bell and say, yes, now I can work as an electrical engineer because I've completed 220 units in this area of study. So the projects for summer camp from Supercharged Science, the goal is different, and how you use it can match the personal educational goals you have for your kids. So if you just want your kids to get out there, enjoy learning, and have fun building some projects, then it'll help you meet that goal. If your kids are a little behind, say in a subject like chemistry, then this will help them catch up. So when fall comes, they'll be more than ready. So there's a lot of flexibility within the program, so it can work with your specific educational goals that you have. Questions, where do we get all the materials for the class? Okay, so for the camp. So a lot of the materials are easy to get, simple. We're talking Home Depot or like a hardware store or an office supply store, or we're talking about like a grocery store. That's most of the projects. Now, when you're building laser light shows, well, here, let me show you. You're not gonna have a MOSFET sitting around or an alien detector. You're not going to have electronics like this one. You'll have the Tupperware, but you won't have like the circuitry, right? And we're actually taking apart a laser in this one to be able to hack into it so you can power it with batteries, so you don't have to keep replacing the special expensive batteries that are in there. Sorry, this is taking a minute. And so in order to get these pieces, there is a master shopping list, and so you can buy these pieces online. So when it comes time to actually doing the projects, and it looks like everybody's accessing this stuff all at once right now. Here, play. See if I can get it to play. Okay, so there's a master shopping list which you can find on this page for all of camp. So you'd click on this link when it becomes active, and then you can pick and choose the labs that you want to do. Okay, all of them, the solar, oh, I can't wait to see the science fair. Me too. Last time we had a science fair, we had amazing entries from kids worldwide. And so you got to actually see the different projects from the different kids from different cultures. Super, super fun. Okay, so other questions about burglar alarms was my favorite. Oh, good. Make sure you put it in the sunlight, everybody. Okay, thank you. Thank you so much. Yes, you're actually right. Rachel liked the burglar alarms. Kristen loved cooking cookies. Okay, awesome. Good, good. Well, thank you guys for sharing. If you have specific questions, do let me know. I'm Aurora at superchargedscience.com. Let as many people as you know, let as many of your friends and family know about what you've been doing with these classes. Share your newfound knowledge, and just be really proud of all the stuff that you've been learning over the past couple of weeks and past couple of months if you've been with us since the beginning. So thank you all so much, and I will see you tomorrow for our Steamboats class. Take care, everybody.